Dan works a part-time summer job making $12 an hour. At the end of the summer, he puts all his earnings in a savings account that earns 3.6% interest compounded quarterly. Write a function rule for E of H, Dan's earnings from his job, where H represents the number of hours he worked throughout the summer. Then use E of H to find the total amount after 1 year of saving using the formula A equals P times 1 plus R divided by N raised to the NT, where A is the total amount, P is the principal, R is the rate, N is the number of times the interest is compounded, and T is the number of years. Simplify the equation with the values for P, R, N, and T in this situation and write the composite for A of H. Okay, so let's just start with the first thing they ask us. So they first ask us for a function rule for E of H, and so we know that E of H is his earnings, and we're also told that he makes $12 an hour. And so we could make a table for this and list out for the different hours and how much he would make, but we can also just think, well, $12 an hour, we know that the total amount he'll make then is just $12 times the total number of hours H. So E of H equals 12H. And then for the other equation, then I'm just copying it again here. So let's just go through each of the variables and say what they'll be. So the amount, we don't know that yet. That's going to be his earnings with interest. P, well, that's the amount he's going to make, and we don't know that. Other than that, we do know it's going to be our E of H function, because that's also how much he makes. So we can even just plug in there, well, that's going to be 12H. And that's where our composition is going to come in right there. So, and R is the rate, and it tells us that he's going to make 3.6% interest, and so that's going to be in decimal form, so it'll be 36 thousandths. And then N is the number of times it's compounded, and so that's going to be compounded quarterly, so that's going to be 4. And then T is the number of years, and here it tells us that it wants to know for after 1 year of savings, so T is just going to be 1 for 1 year. And so now we can just plug everything in. So we still don't know A, but we do know, P, we can actually go ahead and plug in E of H. And so really here, we can actually, let's just rewrite actually. We know that we're going to be plugging in E of H since we're going to put that in to our equation instead of P. So instead of P, we can put 12H, and then we still have 1, and then our rate, 36 thousandths divided by N, which is 4, raised to the N, which is 4, times T, which is 1. And so simplifying this out, then 1 plus 36 thousandths divided by 4 just equals 1 and 9 thousandths. And then raised to the 4 times 1, that's just 4. And so now, just putting this in the calculator, 1 and 9 thousandths to the fourth is just a long decimal 1.036488 and keeps going. And then when we multiply that by 12, then we get 12.43786. So it goes on for a while. So we'll just go ahead and round it to the hundredth. And so that'll be and 44 hundredths. And then we still have H. And that will just be equal to A of E of H. And then in our composition notation, that would be A composed with E of H equals 12 and 44 hundredths H. And so that will be our final answer for the amount that he will make for the number of hours he works and with interest. And so our final answer is Dan's earnings are E of H equals 12H, which is the principal, and A equals P times 1 plus R divided by N to the NT. The composite A of E of H equals 12H times 1 plus 36 thousandths divided by 4 raised to the 4 times 1 simplifies to 12H times 1 and 9 thousandths to the fourth, or approximately 12 and 44 hundredths H. A of E of H can be written as A composed with E of H.